Okay, so now let's look at this problem here. It said that check the following series, whether they are converge or diverge, using the following methods. So this actually is a summary of all type of methods that you can use for series. You can do instern test, the integral test, direct comparison test, limited comparison test, alternating series test, p-series, geometric series, ratio test, and root test. Okay. So for the ratio and a root test, they don't have any restrictions to apply. They work for all type of series. For the p-series, the format is 1 over n to the power p. When p is greater than 1, then converge. When p is less or equal than 1, it diverge, right? Geometric series, it depends on your common ratio. If the absolute value of the common ratio is less than 1, then good to go, converge. Alternating series, right? So, you have to be a little bit careful, for direct comparison or limited comparison test. Those two tests, when you find the comparing series, you have to make sure that both series, they are non-negative for all terms. Okay. If not, you cannot apply any of the tests. Okay. So the nth term test is just to evaluate the limit of the nth term. If it's not 0 or does not exist, then we can directly get the conclusion the series diverge, right? Integral test, you have to verify the corresponding series is positive, continuous, and non-increasing, right? Okay, so let's just get started. Look at the first one. We have 2 over 3 to the power of n plus negative 1 to the power of n over 4 to the power of n here. Okay. So apparently, if we view this, we can treat this as, we can think about it as this, right? We can first consider as the sum of those two series. And even more, for here, you can see both zeros to the power of n. So I can rewrite this one into negative 1 over 4 to the power of n, right? I can definitely do that. Okay. Now, as you can see here, guys, both of the series, they are geometric series. For the first one, so both geometric series. Okay. So the first one, for this, maybe label this is 1, this is 2. So the first one, the first term is 2 over 3 to the power 0, which is 2. And then the common ratio, as you expect, is going to be 1 over 3. Okay. The second one, so the first term, it's going to be 1, right? So which is just this one raised to the power 0. And the corresponding common ratio is negative 1 over 4. So it turns out that the absolute value of both common ratios are less than 1, meaning both geometric series converge. Okay, so the first series, it will converges into 2 over 1 minus 1 over 3, right? So that's the first term over 1 minus common ratio. And then plus the sum of the second geometric series is 1 over 1 minus 4. So it turns out I have 2 over, this part is 2 over 3, right? Plus 1 over, this is going to be 5 over 4. Okay, so it turns out I'm going to have 3 plus 4 over 5. And then if you simplify that, you're going to have 19 over 5. Okay, and of course, both series converge and for sure this series converge. Okay, so this is converge. Now let's look at the second one. Okay, so 3 over m plus 7, right? So for this problem, you can have a couple of different methods. Okay, so what you can do first of all is you can do a limit comparison for this one. How do we do that? Well, we can set the corresponding comparing series 1 over n, which is the harmonic series diverges. So limit as n goes to infinity, 3 over n plus 7 over 1 over n. A equals limit as n goes to infinity. So it's going to be 3n over n plus 7. Turns out this is going to be 3. Okay. And based on the limit comparison test, if this value, if this limit exists, and then both series have the same convergence or divergence property, because the harmonic series diverges, so as this series. Okay, so I know that. Hence, so it diverges. Okay, so this is the first one, or method we can apply. The second way, what we can do here is we can apply the integral test, right? Integral test. So what we can do here is the corresponding function fx is 3 over n plus 7, x plus 7, my bad. X is greater or equal than 1, right? For all the x is greater or equal than 1. It's very easy to prove that the function, it is positive, continuous, and decreasing, okay? Right? So it's very easy. So satisfy those three conditions, we start to evaluate the integral from 1 to infinity, 3 over x plus 7, okay, and then dx. Of course, this is an improper integral, so we have to convert it as integral from 1 to b, 3 over x plus 7 dx. And turns out that, guys, you're going to have 3 ln of x plus 7, okay? And then evaluate it from 1 to b, let b goes to infinity, okay? Alright, so if you put a b inside of this, you will see that this limit gonna goes to infinity, okay? So since this integral diverges, so does my original series, which is 3, let's see, this is 3 plus 7, 3 over n plus 7 will also diverge, okay? So I know that this series diverge, okay? So I'm adjusting the light. Maybe this is better. Okay. All right. So those are two problems here.